everyone. I am Praveen BR, Assistant Professor, Department of Electrical and Electronics Engineering from Vidya Institute of Technology, teaching students of 5th semester Electrical and Electronics students microcontroller theory. In today's session, we are going to do module number 3. Under module number 3, we are doing data conversion program in 8051 microcontroller. We would see how to convert a binary number into a BCD number, how to convert a BCD number back to the binary number, how to convert a BCD to an ASCII, how to convert an ASCII to BCD. Similarly, the different types of conversion. Let us see why is data conversion required. Microcontrollers have a real-time clock where the time and date are always kept when the power is turned off. Even when the power turns off, the time and date are kept. Very often, the real-time control provides the time and date in a packed BCD. So whenever we are talking about the packed BCD, however, the display will always require them to convert it to the ASCII. What do you mean by an ASCII? The full form of ASCII is American Standard Code for Information Interchange. What is an ASCII? An ASCII is defined as a character which is used for encoding standard for electronic communication. ASCII code always represents the texts in computers, telecommunication equipment, and other devices. ASCII keyboard has, when I press key 0, whenever it gets activated, it goes to 30H. That means 00 will be added with 30. So it goes to 30H. So 30H will be provided in the computer. Similarly, whenever I press 1 in the keyboard, it goes for 31H. So 31H means always it keeps adding 30 to the number. So if I press 0, it is 30. If I press 1, the ASCII equivalent is 31. So like that, it keeps on going up to 9. So this is the ASCII table. So let us see next how to convert a BCD number into ASCII. So let us proceed with the next slide. So in the ASCII table, you can observe I have a key, I have an ASCII, I have a binary, and I have a BCD. BCD, there are two types. One is packed BCD and the other one is the unpacked BCD. So coming to the packed BCD to ASCII conversion, the real-time control always provides the time of the day. It has the date continuously regardless of whether the power is turned on or turned off. However, this data will always be provided in packed BCD. To convert the packed BCD to ASCII, you must first convert it into unpacked. Then after you convert it to unpacked, you have to add 30 to it so that you will get a ASCII converted number. So let us see how this conversion happens. So this is called packed BCD to ASCII, wherein a given number is in packed BCD, it is converted to unpacked, and then from unpacked it will be converted to ASCII. So there is a protocol which we have to follow: packed to unpacked, unpacked to the ASCII format. So this is how we are going to do. Let us see how ASCII is converted to BCD. To convert ASCII to BCD, first it has to be converted to unpacked BCD. For example, if I have 4 and 7 on the keyboard, it gives 34 and 37. Means the number 47 is divided into 2, the most significant bit and the least significant bit. The most significant bit is added with 30, which gives you 34. 7 is the least significant bit, which gets added with 30, which gives you 37. So 34 and 37 are the numbers which you are going to get. After this conversion, the packed BCD numbers are processed and the result will be stored in packed BCD format. So this is with respect to ASCII to packed BCD conversion. So we have learned how to convert a packed BCD to ASCII and how to convert an ASCII to packed BCD. Now let us see what do we mean by counter programming. So we have seen timer programming where we had used timer 0 and timer 1, and by pressing T bar as 0 we got to know that we had used it as timer. Now if I would like to use it as a counter, C/T bar should be equated to 1 such that it will be used as counter. And always for the counter you are going to connect it to the external clock pulses, and external clock pulses are fed from the 14th pin and through the 15th pin of the microcontroller. So especially 14th pin and the 15th pin are the ones which are going to be connected to the external frequency, because in the case of counters we are going to make use of the external clock pulses. In the case of timers we use internal clock pulse, and in the case of counter we use external clock pulse. So to activate the counter we need to load 1 in the place of C/T bar in the TMOD register, which will ask the controller to function as a counter. So this is how we are going to activate the counter and the modes. And the same modes whatever we have spoken in the case of timer, the same modes are going to be applicable even in the case of counter. So as I told you, there are 4 modes of operation: mode 0, mode 1, mode 2 and mode 3, where mode 0 is called as 13-bit mode, and mode 1 is called as 16-bit mode, and mode 2 is called 8-bit auto reload mode, and mode 3 is called as split mode. So these were some of the programming which we have learnt even in the case of timer. So the same thing is applicable here even in the counter programming. Only thing that changes is the 6th pin and the 2nd pin, where C/T bar when it is given you have to tick. So now let us see what are the steps we have to write for the counter and to print it in on the LCD. The first and the foremost thing which we have to make sure is to initialize the TMOD register to make it either timer or counter function as a register. For timer 0 mode 1 operation, we have to set the value of the TMOD as 05, load the initial value from where you have to start the counter, I mean to say TL0 equals to 0. Then you have to start the timer 0 to start counting by feeding the logic 1. That means by giving TR0 equals to 0. Sorry, TR0 equals to 1. So whenever TR0 equals to 1, you are setting the timer bit, timer 0 bit. To display the count values in the LCD, you have to copy the TL0 values to an integer in our program where we use it as VAL. The LCD cannot display an integer, so we need to convert the integer back to the character. For that purpose, we use a command called sprintf, ch%u VAL, which converts the integer VAL into the character. Then we have to display this character in the LCD. So this is how we are going to use the program for counter and print it in the LCD. So this is the steps which we use in the LCD program. So thank you for watching the video. Thank you.